Get started here. Thanks so much for joining us for our session today. We're going to be talking about preventing unauthorized credentials from being leaked on GitHub.com. So I'm joined here by Welly Sao, who's been our partner in crime over on the AWS side, working with us on all things GitHub. So really excited to have a few minutes to share some of what we've been working on this year. So the first thing I want to talk about is sort of what secrets management looks like at scale. At GitHub, we're a huge developer platform, and so thinking about the volume of credential leaks that can happen on a platform of our size is really interesting. So we'll kind of dig into the challenges that creates. We'll talk about how AWS and GitHub are working together to improve the overall security posture of AWS and GitHub, but also kind of the internet generally, and sort of what that looks like. And then we'll talk about a couple of best practices for obfuscating API credentials that you're using in your application. So just as a primer, GitHub is the world's largest developer platform. We have over 100 million users on the platform, making over 3.5 billion contributions annually. If you don't use GitHub today, you should go create an account. Everybody who works in technology should have a GitHub account. It's like the place to come collaboratively build software. But what that means is we see a lot of traffic on GitHub, and really interesting traffic. And today what we want to talk about is secrets, right? So on GitHub, we find millions of tokens annually that developers have accidentally copy and pasted and leaked in their code. And oftentimes, they don't even realize that they've done this. They maybe copy and paste an API credential into the code, and then they think about remediating that or fixing it, and they just delete that commit, or they delete the text and then they re-push the commit, and they don't realize that the full commit history is actually saved in Git. So even though the token isn't present in the main push, it is in the commit history, and so they've leaked their credential onto the platform. Malicious actors are looking all the time for these API credentials that may be leaked. I did a demo last year where I actually leaked a credential live, and within about 10 minutes, 17 people had picked up that credential and tried to fraudulently use it on my AWS account. So it cost me about $150 to run that demo because I turned up a large instance in every major geo in the world. So people are looking for this. So what we did is we built a service with Amazon, and we said, hey, we have all these commits coming in, and if we have a clever way of identifying whether or not that commit has an API credential, we could scan for it pre-commit. So before we write the commit to the GitHub backend, we scan it for potentially leaked secrets. And we worked with AWS to dial in a regular expression that identifies AWS access tokens and access keys on the platform that may get leaked. Once the secret is in GitHub, if the alert or if the secret is leaked in a public repository where it would be available on some github.com/ whatever, somebody could go and find this, we actually send a notification to Amazon, and they'll send you an email, they'll quarantine your account, they'll open up a support ticket, and they'll start a remediation process with you to help you rotate that credential. And where we'll share in the future is we're actually starting to block the commit at this layer. So we'll kind of show you how we get into a more proactive posture as we go through this discussion. But before we get into that, let's talk about what should have happened, because it's easy to leak credentials, but what your team should be doing is using a tool like AWS Secrets Manager and using temporary credentials through OIDC so that you're not using hard-coded credentials at all. And so Welly's going to talk a little bit about how to use AWS Secrets Manager properly, and about a GitHub action that we worked on to help you rotate credentials so that you don't run into this issue in the first place. So you want to take it away, Welly?
All right, thanks, Jose. Once again, my name is Welly. I'm from AWS. So earlier we talked about how we can solve this problem together. So let's start with the first part, which is the AWS Secret Manager. Anyone in here have used AWS Secret Manager? Raise your hand. Awesome. In case you haven't used Secret Manager, this is really a managed service to allow you to manage, retrieve, and also rotate credential. So credential can be anything from database, username and password, token, or maybe other access key and secret key and other things. What's really nice about AWS Secret Manager is that it's also encrypt those secrets as you store it. And then you use AWS KMS, or Key Management Services, in order to encrypt those secrets that you have. You have an option, for example, to use customer managed key if you prefer to manage your own key, or you can also use service provided key in order to just let Secret Manager handle that. Now, the other thing that's really nice about Secret Manager is that everything you do, from creating the secrets, storing the secrets, rotating the secrets, deleting the secrets, is all tracked into an audit log in the AWS CloudTrail. Anybody here have used AWS CloudTrail or heard about it? Perfect. Yep. So what's really nice about it, then you can track all of those activities in the CloudTrail. And then you can provide fine-grained IAM permissions using the IAM policy, for example, to define who have access to the secrets. Now you have two options. You can do identity based on the principal. So you attach a policy to the IAM role or IAM users. Or you can also do resource-based policy in Secret Manager. This is something new that just recently been launched, that you can define who have access to the secrets directly at the resource level rather than in the identity level. Now, Secret Manager, what I also really like is that it actually automates the rotation of the secrets. Now, if you deal with like a database credential, for example, you know like how challenging is that to actually rotate that every couple months and etc. With AWS Secret Managers, it's actually integrated with Amazon AWS RDS or Relational Database Services. So you can automatically rotate your credential in the database on the RDS. Now, let's say you have another types of database or applications. Perhaps you have like on-premises applications or you have custom application. You can use AWS Lambda to be integrated with RDS in order to automatically rotate that credential as well. And then if you are doing like a multi-region, multi-accounts setup where you have your workload spread across the region, you can also do like secret replication through the different regions. So Secret Manager is the key in order to store your credentials instead of storing it statically in your Git repository and etc. But how you actually do that, this is where we work together with GitHub, where we created these Secret Manager actions. So if you are using GitHub, of course you know GitHub workflow or GitHub actions. And here you can actually run that as the GitHub workflow that retrieves the secret dynamically. It stores into an environment variable and allow you to have this credential available dynamically, and then based on authentication you do through IAM. Now, this is just a quick example of how you can do that. I have a quick demo that we're going to show you how this is going to work in actions. The other part of secret management is actually credential, right? Because you have to use credential to access anything in AWS. And ideally, you don't want to hard-code those credential, access key, and secret key. Just like what Jose mentioned earlier, you don't want to commit that into your repository. Now, in here, we always recommend that any workload, machine-to-machine communication in AWS, to use IAM role because it provides you with that temporary credentials. It's time-bound, it's ephemeral, so then you don't have to deal with storing that credential somewhere and also distribution of that credentials. So I suppose everybody here familiar with IAM role. IAM role allows you to basically assume a role. You can set the limit like for 1 hour and etc. But you can also automatically rotate that credentials. And guess what? Inside of the GitHub workflow, you can also use the IAM credential. So in here we have this action called AWS configure credentials. This is also another work we did with the GitHub team in here when GitHub added this OIDC or OpenID Connect as the identity provider. And that allows you to basically authenticate to IAM using your GitHub credentials. And then from there on, you can specify what is the role that you want to use, set the session durations, and now you no longer have access key and secret key within your repository. Again, really want to change that perspective in how you develop your applications. So remember the diagram that Jose has before, right? The idea in here is that you do your commit, you don't have to put any secrets inside of your repository. In case you have to do that, or in case like you make any accidental, there's a secret push protections, which Jose will talk a little bit more about it, that allows you to actually prevent those commits to actually happen into your repository. And then you can dynamically retrieve the credentials and also any secrets that you have using the IAM actions that we have mentioned earlier, and also the secret manager actions. Jose, you want to talk a little bit, before we go to the demo, want to talk a little bit about the secret push protections?
Yeah, so this is really cool. So basically, as I was saying before we write the commit into the project, we'll finish this static analysis scan, looking for AWS keys and any other API keys that we're aware of. If we identify any, we'll actually fail the get operation. So it won't ever be written. That credential doesn't have to get rotated. It's never been publicly leaked in any way. So it's still secure, and you can continue using it. What you'll get in the IDE is a standard out from the IDE saying, hey, at this line number, it looks like you've committed a credential. The administrator of the GitHub account can also set a custom URL that would point to maybe an internal wiki page or something of that sort that redirects users to properly store secrets using AWS Secrets Manager, following whatever practices you have internally. So the user will get kind of just-in-time education at the time that they're making the commit, and then be able to go and fix the commit before publishing the credential. So by doing that, we save a lot of time. We also kind of educate everybody on how to properly store secrets.
Thanks so much, Jose. So let's go to the demo. I have this demo recorded just because I don't want to typing and make you guys waiting, because we only have like 8 minutes in the clock right now. So here's the demo. Let's see if it works. In here, we are going to use Terraform. So I have a very simple Terraform to create an S3 bucket. And then I also use Terraform Cloud for this particular purpose. That's why I have my token, which is I stored in the Secret Manager. You can look at one of these tokens in here, for example. You can see that it's using an encryption key from the Secret Manager. So this is not the customer managed. This is service managed encryption key. And then you can notice also there's a path, right, for each of those secrets. I also want to authenticate to AWS using GitHub. So in here, I set up my IAM role. And this IAM role has a very limited permissions. It's only to retrieve a secret, essentially. And then I specify the resource name for the secrets that I want to retrieve. And in order to make it authenticate to GitHub, I set up this identity provider in here. And then I can specify which particular repo that I will allow this authentication to happen. So how do we make it work in the GitHub workflow? So the first thing is that you set up your actions. Here I have a couple environment variables to specify the name of the role that I want to use. And then I specify that role within the action itself. So I can say, like, you want to assume this role, and then store that inside of the action itself. Now, once I have the actual role, then I can authenticate to AWS from the GitHub workflow. Next thing I can do is that actually using that authentication to then retrieve my secrets. In here, I'm retrieving the Terraform token. So I'm using the Secret Manager actions. I specify 3 environment variables where I'm going to store those secrets. And notice the path in here. That's the same path that I have in my Secret Manager. All right. So from there on, I have my credentials. I have my Terraform token from Secret Manager. The rest of it is just like running the Terraform plan and apply. And I'm using those environment variables inside of my workflow in here. You can see some of those environment variables being highlighted right now. And then in this case, I'm going to make a pull request. So this workflow runs based on the pull request on the Terraform files. So if you look at the repository itself, I already have my pull request running. If you look at this pull request and look at the checks that are running, we can see in here the first thing it does is that it's retrieving the AWS credential. And then based on that credentials, it pulled the Terraform token by using the Secret Manager. And then when I have those tokens, I can finish the rest of my Terraform plan and apply directly inside of the GitHub workflow. Now, just to kind of verify the result, I can come back to this pull request. I can make the bot to actually make a comment. And here you can see the comment from the bot when I did my Terraform plan. Now, let's say I make a bad choice. For some reason, I like to store my credentials, right? You see in here, I have a single file that has my access key and secret key. This is no longer valid, so no need for you to take a screenshot of it. But let's say I make this very bad choice for some reason, right? And I'm trying to become a bad actor. if I try to actually make a commit and push this into the repository that I have in GitHub, notice what's going to happen. So GitHub secret push protections will actually prevent that from happening. So it detects that there is an access key and secret key based on the pattern in your repository, and then it rejects it. You have the URL in here if you want to, where you can actually say, you know what, I really, really want to have this in my repository. But you really have to think twice if you want to do that. It's also detect like a Terraform token, so any other secret push protection partners that Jose mentions will be detected as well as part of this whole process. All right, that's our demo. Key takeaway from this call, I know I'm showing a lot of codes and etc. Really 3 things that I want you all to come back home. First, always use IAM role for access to AWS. If you can, use it. If you have to use access key and secret key, like a static access key and secret key, ask yourself again, why do I need this? Is there a way for me to use IAM role? And that should be your first choice. And then if you have any other secrets, any other credentials that you want to store and retrieve, you can use AWS Secrets Manager in order to help you manage those secrets, the rotations, the encryptions of those secrets as well. And again, today, after you go home, look at your public repository, enable that GitHub secret push protection. Please, you never know what's going to make mistake, and we want to make sure today you feel more safer after you're done with this call. So with that, thank you so much. I really appreciate your time and your investment. I hope you find this is useful. We're going to be here around if you have any other questions. Thank you.